Have you ever wondered how a tiny insect, like a fly or a bee, can zip around, make sharp turns, and hover in midair, even when the laws of physics say they shouldn't be able to fly? Today, we're exploring the fascinating world of insect flight and how these tiny aerial acrobats have inspired cutting-edge technology. For years, scientists were baffled. According to the equations, insects should be too heavy and their wings too small to fly. Yet, there they were, buzzing around without a care. So, what was going on? You see, while airplanes use fixed wings to generate lift, insects do something entirely different. Their wings flap, twist, and sweep in ways that make traditional aerodynamic theories seem almost irrelevant. To understand how insects fly, we have to look at their wing movements. Instead of just flapping up and down, insect wings trace out a complex figure-8 pattern. This allows them to generate lift on both the upstroke and the downstroke. It's like they're swimming through the air. Insects also use a clever trick called vortex generation. They create tiny whirlwinds along their wings, which give them an extra boost of lift, letting them hover, dart, and make those sharp turns. It took scientists decades of research, high-speed cameras, and even mechanical models to figure out how insects manage their flight. Researchers like Charlie Ellington and Michael Dickinson spent years studying everything from blowflies to hawk moths, and discovered that the secret was in the complex, dynamic movements of their wings. But here's where things get even more interesting. Engineers thought, if insects can do it, why can't we? So they began designing tiny flying robots, known as micro-aerial vehicles, or MAVs, that mimic the way insects move their wings. Micro-aerial vehicles are like mini drones, but much more agile. They're designed to be as nimble as insects, able to dart around corners, hover in place, and navigate through tight spaces. Imagine a tiny flying robot that can slip into a collapsed building to search for survivors, or fly through a dense forest without crashing. We needed something that could maneuver rapidly in tight spaces, and flapping flight turned out to be the best solution. It's not about making something that just flies. It's about creating a machine that can move like an insect. Sounds futuristic, right? Engineers have already designed machines that can flap their wings up to 150 times a second, using special lightweight materials like carbon fiber and polyester. The key to their design? Resonance, keeping the wings moving efficiently, like a perfectly tuned musical instrument. So, what's next for these tiny flying robots? Engineers like Ron Fearing are working on making them smarter, faster, and more efficient. Imagine swarms of MAVs, each one designed for a specific task, from search and rescue to surveillance, or even just delivering your lunch. But to make this a reality, the MAVs have to master what insects have been doing for millions of years. Perfect control. Just like a fly that can turn 90 degrees in a fraction of a second, these machines need to make sharp turns, dodge obstacles, and adapt to their surroundings with ease. And it's not just about wing movements. Insects have highly advanced sensory systems. For example, a fly's eyes can process up to 200 images per second. That's one of the reasons they're so hard to catch. Engineers are trying to replicate this by using tiny gyroscopes and sensors, giving MAVs a similar level of awareness. It turns out that by studying how nature handles these complex tasks, we can create machines that are not just smart, but nimble, fast, and highly efficient. So the next time you see a fly buzzing around, remember, you're watching a master of micro-aerobatics. Who knows? The next breakthrough in robotics might be inspired by that little insect buzzing by your window. Thanks for watching. Be sure to like, subscribe, and share. Stay tuned for more amazing insights from the world of science and technology.